Hi everyone, welcome to the video. We are going to solve serialize and deserialize a binary tree. In this question, we are given a binary tree and we have to perform two operations. By serialize, we mean we'll convert the tree into an array and we'll return the array. And by deserialize, we will mean we'll again convert the converted array, or let's say the array, to the binary tree and will return the root of the tree. So how we'll do it? But first, let's see with example. In example 1, the binary tree is of three nodes 1, 2, and 3, and we return the answer. But see, what is the output? 2, 1, and 3. Isn't it similar to the in-order traversal? 2, 1, and 3, left, root, and right node. Let's see with example 2. It has 5 nodes now 10, 20, 30, 40, and 60. This is again same as what we have in order traversal. This 40, 20, 60, and 10 and 30. Left, root, right. Okay, that is how we do. Much similar to the in order traversal. Okay, now first of all, how we will deserialize it? So I will create an array which we need to return, and then I will create a utility function since we are employing recursion over here. Okay, I will pass the root over here. How we will call it? We'll call this function with the root and we'll return the array at the end. But how we will fill this function? First of all, we'll check if there is root or not, if root or none, which means whether we have reached the last node or not. If we have reached the last node, return it, return nothing. But if we have not reached the last node, leaf node, and we still have elements, okay, then we'll recursively call our function in the left subtree. Okay, then whatever we have, we'll append that in the array as root.data. Then again, we'll call our function recursively with right side of the tree, right side of the tree. So this will do the job to serialize, or let's say convert the binary tree into an array. But how we will deserialize it? How we will deserialize it? First of all, how we will call it? Again, I will create a function, utility function, which will take three things right now. First, which is the array itself, then a starting index and an ending index. But how we'll call it? So we'll call our function with a starting index initially will be 0 and ending index initially will be length of a minus 1. Length of a minus 1. First of all, the base condition, if a start is more than end, which means whether we have reached out of the bounds, return it. If not, if not, create an index which will be the middle of this, and create a root node with this index element. Root node with this index element, because we saw in example 2 the root node is in middle, and how that is how we have serialized it also. It is left node, then root node, and then right node. So here middle one is root. Then how we'll do it for the left subtree? Similarly, we'll call our function recursively with left subtree, but this time start will be there, but ending will be till index minus 1, middle index which we have calculated, because that index element ind is root. So we are going root minus 1 till root minus 1. Okay. Same way we'll call our function again with right subtree, but this time it will start from index plus 1. Index plus 1, because index we have already included in the root. Okay, so left went from start 0, so let's say start to index minus 1, index is the root, and then right is index plus 1 to the very end, cool. At the end we need to return the root, that is it. This should do the job. Let me submit and check the efficacy of our solution. So it is saying some error. Okay. It's saying that I have not written anything. How come? Let me pause and check. Okay, so I missed this return over here. I just called my function but have not equaled the return. So let me submit and check the efficacy now. Okay, yeah, as you can see, it does the job pretty effortlessly in very less time, even though it is recursion. So I hope you learned a new concept and enjoyed it. Thank you. Have a very nice day.